All right, today we are starting section 7.1. It's about the nth roots and rational expressions. This kind of looks weird. Nth root just means different types of roots. So we'll do square roots, cubed roots, fourth roots, fifth roots. So really any type of roots we're going to look at today. So our goal is to evaluate nth roots for real numbers using both radical notation and rational exponent notation. So we will learn how radicals and fractions and exponents are similar today. Any questions so far? All right, so just kind of a review of radicals. I'm sure you've seen something like this before. This little number out front, that's the nth root. Whatever the n is called our index. If there is no number written in front of the root, we know it's just a square root. So it's like having an n of 2. When the n is 2, we don't write it. The number inside is called the radicand. And then the symbol is called a radical. That's not really written. I assume you guys know that by now. Saying the nth root of a is like saying what number to the nth power would result in a. Here's our first example. So I'm telling you what n is, and I'm telling you what a is. So you have to take those two numbers, basically tell me what it means, and then tell me what the answer is. So remember, we talked about how when your index or your n number is 2, we don't need to write it. You can just write the radical. And then the a number, that's your radicand, that goes inside. I'm sure this is easy for you all. What is the square root of 16? 4. And remember, you could do negative 4 times negative 4 and get 16, or positive 4 times positive 4 and get 16. So we have to think of the plus and the minus here. Any questions? All right, here's the next one. So we want our index to be 3, and hold on, our index to be 3 and our radicand to be negative 1. So go ahead and try to write that one. All right, so when I write this one, my index now is 3. Anytime you have an index besides a 2, you need to make sure you write it. We write it small in front of the radical. And then the a, that's our radicand, that goes inside. So what number to the third power would give you a negative 1? Negative 1. No plus or minus here. The only number that works is negative 1. All right, here's our third example. So the n number is our index. That's going to go in front of our radical. So we want the little 4. And then we want a 16. A negative 16 as our radicand. So inside the radical, we're going to write a negative 16. You would say this out loud as the fourth root of negative 16. So what number to the fourth power would give you negative 16? Well, 2 times 2 times 2 times 2 is positive 16. Negative 2 times negative 2 is positive 4, times another negative 2 is negative 8, times another negative 2 is positive 16. Check the directions. We only want real solutions.
What would be positive to negative?
That would be 16, just like number 1, but since that's a fourth root now, it'd be 2 instead of 4.
No real solution.
Yeah, exactly. No real fourth root here. Again, when your index is an even number, like 1 and 3, there's no way to get a real solution. This is where we'd have those i's. But the directions here say only real roots, so you would just say no real roots. However, anytime you have something to the third power, you can get a negative number because it's a negative times a negative times a negative. So if your index is odd, just make sure your answer is negative. But if your index is even, you won't have any real solutions. Any questions on that idea? All right, here's another example. So how would I write this? What would the next line look like? Yeah, the third root of 125. So you have the 3 as your index, the 125 as your radicand. Now, what number to the third power gives you 125?
Plus or minus 5.
Just positive. If you had negative 5 times negative 5 times negative 5, that'd be negative 125. So you don't have the plus or minus here. It's just 5. Questions? Here's the next one. How would I write it? Oh, is that what you're going to say, Matt? Thanks. 3 square root of 0. So it's like saying what to the third power would give you 0 as your answer? 0. Good. Here's number 6. All right, how would I write this? Square root of 49. Do I need an index? No. When your index is 2, you don't need to write anything. This is just a square root of 49. I heard a couple of you say it. It's plus or minus 7. Now, you guys all know like the factor tree method for this. If you ever get stuck, I've seen you guys do the factor tree for a square root. It's the same thing for a cubed root or a fourth root, except now you're looking for groups of 3, or a fourth root you're looking for groups of 4. So if you get stuck, these have all been pretty easy. I didn't see the need for a factor tree, but don't forget the factor tree trick if you get stuck. And just remember, whatever your index is, that's how many you're looking for. So like square root, we would circle it in groups of 2. If it was a cubed root, you'd look for groups of 3 of the same factor.
And you do not want us to have a calculator?
Today is no calculator day. Tomorrow, calculator. Now, am I going to like police you and walk around while you do your homework tonight? No. So technically you could use one, but I would like, as far as class discussion, to just be no calculator. All right. Here's the next thing we're going to look at. This is how you would write something to the nth root using exponents instead of radicals. So whatever the root was, let's say the square root, you would have your exponent as a 1/2. If it was a cubed root, your exponent could be a 1/3. A fourth root, your exponent would be a 1/4. This is basically just another way to write it where you don't have radicals, you just have exponents. Now, these are not actually too tricky when you have 1 over some number as your exponent, but sometimes you might have a number on top of another number that's not 1. Those get a little more tricky, so here's just kind of in general how it works out. If you have a to the m over n, whatever the n is, that's your root. So if it was a 4 on the bottom, it'd be a 4th root. If it was a 5 on the bottom, it'd be a 5th root. Now, as far as the m on top, you could either put it all the way outside and just deal with it, take the nth root of a and then take it to the m power, or there's actually another way to think of it, and we'll look at examples so you don't have to feel overwhelmed with these m, n's, and a's. You could actually take a to the m root first, or sorry, a to the m power first, and then the nth root. So this and this mean the same thing. They're interchangeable. Sometimes it's easier to put it inside the radical, sometimes it's easier to deal with it on the end. But in general, this is how rational exponents work. So this might not mean a lot now. I would definitely write this down, because then when you have numbers, you can refer back and say, well, in this example, m is 2 and n is 5, and it'll kind of help you set up your problem. Any questions on this? All right, so example 7, we have 27 to the 2/3 power. So you know that the denominator of your exponent is the root that you're taking. So this is like saying the cubed root of 27, and then the numerator deal with afterwards. Or, like I was saying, in some cases, it'd be easier to do 27 squared and then take the cubed root. But in this example, do we know what the cubed root of 27 is? Yeah, what is it? 3. So it's much easier to do that first than to do 27 times 27, right? So we're just going to do the cubed root of 27 first, and then we're going to square the result. So you guys already said that was 3, and then 3 squared is 9. Very good. Now, just looking forward in the future, I believe that the calculator will do this for you. You would hit the 27 and then that little caret button, and then make sure in parentheses you do 2ABC 3 or 2 divided by 3, and then close the parentheses so it knows that that's all part of your exponent. All right, but for now, no calculators. So we have 343 to the 1/3 power. So if I wanted to write this with radicals, what would it be? With radicals. Now, hold on. I'm just going to correct your notation. If you say 3 square root, saying square root implies that 2 is your index, but we want 3 as your index, so how would you say that out loud? Cubed root. Or you could say the 3rd root. I would know what you meant. But yeah, cubed root is typically the way it's said. Now, what happened to our numerator of our exponent? Where'd that go? It's a 1. So really, we're taking 343 to the 1st power. You don't need to write it, of course. So this is just the same thing as the cubed root of 343, which is 7. All right, here's our next example. 81 to the negative 3/4 power. So what's going to become our index? 4. 4 becomes our index. Now, you have some options here. You can take 81 to the negative 3 power, or you can deal with your root first and then take it to the negative 3rd power. I think it's easier to do it afterwards. You can experiment with both if you'd like, but this is the way I'm going to think of it. Because what is the 4th root of 81? 3. Now, do you guys remember how we deal with negative exponents? It was our first lesson in the last chapter with the rules of exponents. Where do negative exponents end up? The bottom of a fraction. So, what is 3 to the 3rd power? 27, and then you just put it in the bottom of a fraction. So, it'd be 1 over 27. The reason it goes to the bottom is because we have a negative exponent. Negative exponents, you just take the reciprocal. So, if it was in the bottom, you move it to the top. This was in the top, so you just move it down to the bottom. And the number becomes positive. A big mistake is people want to make it a negative 27. The way you deal with the negative is you just move it down. You don't change the sign of the whole answer. All right, what's the 5th root of 32? 2, good. That's why I said it's important to know, especially the smaller numbers. Like 2, you should know what 2 to the 4th is, 2 to the 5th, 2 to the 6th, 3 to the 4th, 3 to the 5th, 3 to the 6th. You might see those coming up. Technically, we could use any number, but the smaller ones are the ones you'll see more often. All right, here's 11. We want the cubed root of negative 8. Negative 2. Good. Negative 2 times negative 2 times negative 2 is negative 8. Now, number 12 is another one where if you wanted to take this 3 and move it to the inside, sometimes that makes the problem easier. I don't know about you, but I don't want to do 36 times 36 times 36, so I'm just going to leave it where it is. What's the square root of 36? 6. So now it turns into 6 to the third power. What's 6 to the third power? 216. We talked about it in our warm-up. Good. Questions? Alright, that's all we're doing today. So here are your homework problems. If you want to try actually the whole assignment, you can look to day 2 and see what it is. But we are going to talk about that specifically tomorrow. What we've learned today is covered in problems 13 to 40, just the odds.